All right, moving on. So looking at question number 15. So starting with number 15, the first thing we gotta do is recognize that here we have a tangent, which means 90 degrees. And they're asking for RS, so they're asking for this distance here. Now notice that from P to R represents the radius. That means that from P to T is also the radius, which is 3. Which makes it a little bit easier because we know this entire distance now is not 7 or 3, but is actually 10. And so if you notice, we have a right angle here, which means we have a right triangle here which means that we have to use Pythagorean theorem. Now, for Pythagorean theorem, remember, A and your B don't matter. What does matter is what you call C, and C is always going to be your longest, or the hypotenuse. So across from 90 is 10, so that's what we're going to call C. And what we're looking for, we'll call it A, and what we know is B. So remember, Pythagorean theorem, right off to the side, we have A squared plus B squared equals C squared. Now in this case, we're looking for A. So A is going to be whatever the square root of C squared minus B squared. And we substitute in what we know. We know C is 10. And we know B is 3. And so A, or RS in this case, is going to be whatever the square root of 91, or if I put it in the calculator, I get an answer of 9.54. Moving on to 16. Now, if you notice, segment KL is a chord, and because the radius is perpendicular to that chord, the property tells it that these two segments are going to be congruent. And the next part, they're telling you down here, they're trying to hide it, they're telling you OK or KO is 5. That means the radius is 5. And so here we have, one more time, Pythagorean theorem. And so we're looking for this side down here. We'll call it A. Here's B. Here's C. So we apply Pythagorean theorem. Remember, Pythagorean theorem is A squared B squared equals C squared. We know C, we know B, we're looking for A. So A is going to be the square root of 5 squared minus 3 squared, or in this case, A is going to be 25 minus 9, or 16. The square root of 16 is 4. And so here, this little a is 4. And so if that's 4, that means this piece over here is also 4, which means KL is 8. Moving on to 17. So once again, notice how we have a chord and the radius is perpendicular to that chord, which means two things. One, these two segments are congruent, and if we were to draw the radius here, these two angles are also congruent. So if CK is 30, that means PC is also 30. And they're telling you that from A to K is 8. So if this is 8 here, that means P to A is also 8. And they're asking us to find SC. So for 17, we have to think way back to when we're talking about special right triangles. So notice how this arc CK measures 30 degrees, which means this central angle here also measures 30 degrees. And if that's 90, that means this is 90, which leaves this to be 60. And so now we have a 30, 60, 90 triangle. And if you can't see the triangle, that triangle is right here. And so we have a 30, 60, 90, which means we have to label it. Across 30 is x, across 60 is x root 3, and then across 90 is 2x. So we have information for the x part. And so here we have x equals 8. If we know that x equals 8, whenever we replace x here, we get the radius to be 16. And that's important because if the radius is 16 and they're asking for information from C to S to C, notice how SC represents the diameter. And so since we know that the radius is 16, that means that the diameter is going to be twice that. So the diameter here, SC, is 32. Moving on to 18. Notice how these 2 points do not go into the circle or through the circle or stop at the circle. They only touch the circle once, which means that these 2 rays are tangent. And because they're tangent, it's telling us that these 2 segments are going to be congruent. And so if we know that they're congruent, we're going to set them equal to each other. So we have 62 is equal to 7x minus 8. And we're going to solve for x. So the first step is we're going to add 8 to both sides, which gives us 70. And then the last step is to divide by 7. And we get x to be 10. So moving on to 19. Here we have 2 chords. So here's one of the chords. And here is the second one. And so to solve for s, we got to set up our equation. And so we have part of one chord, which is 4x, equals to the other part, which is 7 times 8. And we're going to solve for x. So 4x equals 56. Divide both sides by 4. And we get x to be 14. Alright, moving on to 20. There's no 20. Moving on to 21 then. So look at 21. So 21, we have our angle outside of the circle. And we're given 2 measurements. We're given the small arc, which is from here to here. And we're given an additional arc, which is not really the one we want, but it's helpful because we have to figure out what the arc measure of the big arc is, which is this one here. So to find the measure of that arc, all we're going to do is, we know a full circle is 360 degrees. So we're going to subtract 100, and we're going to subtract 60, and that whatever we have left, that is a measurement of that arc, which gives us 200 degrees. And so now to find the measure of x is going to be whatever 1/2 times the big arc, which is 200, minus 60 is. So 200 minus 60 gives me 140, and half of that is 70. So moving on to question number 22. We have a regular hexagon. Now that's important because all the angles and all the sides are going to be congruent. So all of these sides are going to be congruent, which tells us that each one of these arcs is going to measure exactly the same. And so the easiest thing to do here is notice how we have 6 arcs here, 6 arcs that measure the same. So we're going to take our full circle, which is 360, and we're going to divide by the number of sides, or the number of arcs, which is 6, which tells us that each individual arc measures a total of 60 degrees. And so here we're asking for the measure of arc HE. The measure of arc HE is going to be 60 degrees. 23. So 23 is telling you, well, first of all, we have a chord here, here. And they're telling us that the measurement from here to here is 5. Now that's important because if you notice, the measurement of 12 represents the radius. And so if I were to draw the radius from here to here, that means that that's also 12. And from here to here, that's also 12. So I'm going to go ahead and label that 12. Now, if I already know that from here to here is 5, that means that from the radius to the point of intersection is not 12 and it's not 5, but it's actually 7. And what that does for me is it outlines this rectangle, this right triangle that I'm going to use Pythagorean theorem on. And once again, what we call A and B does not matter. What does matter is what we label C. And we're going to use Pythagorean theorem to figure out what we need. So here we're looking for A. So A is going to be whatever the square root of 12 squared minus 7 squared is. So put that in the calculator and we get an answer of 9.75.